Alright, now we are ready to start with our first algorithm, which is called Gaussian naive Bayes, or some people call it bias. Now this is a really simple and nice algorithm. It's very fast and it can do a great job in classification. And it is actually based on the naive Bayes probabilistic algorithm and the Gaussian distribution. And this is of course an algorithm that is categorized as supervised learning. Do you remember why? Because we need a label. Okay, so let's see how this cool simple algorithm works. Let's try to solve this simple problem. Let's say that we are trying to classify if a person likes to use his car or not based on a certain information. So here, let's say that this is people who like to use their car. Alright, and here we have the people who don't like using the car. And let's say we collected some information, and this information can be represented as follows. Let's say it depends on their consumption of fast food per day, how many meals. Let's say it also depends on how many times they exercise a week, and also how many kids they have. As you can see, we have these four categories. And let's say that we have multiple samples for each of them. Here, I'm going to say this is maybe the first sample, second sample, etc. Let's say that here we have around eat 3 meals a day. All of them are fast food. They exercise only once a week and they have 2 kids. And here maybe we're going to say they eat once a week, they never exercise, and they have 1 kid. And here maybe they eat 4 times a week, they never exercise, and they have no kids. Now let's fill the people who don't like to use the car, for example. Let's say here that they don't eat fast food, they exercise 3 times a week, and they do have 1 kid, and etc. We can just fill these as we want, alright? Now, these are the data that we have. How are we going to solve this problem with Gaussian naive Bayes? Well, first thing, we need the Gaussian distribution for all of these. First, let's start with people who like to use their car. We are going to calculate the standard deviation and the mean for this data, all of it, okay? So if we do that, we would get, let me draw this. Let's say that we got a Gaussian distribution for people who like to use a car, and for the number of times they eat fast food is like this. This is the Gaussian distribution for that. And now let's draw the same thing, the mean and the standard deviation for people who don't like to use a car for the number of fast food meals they eat per day. And let's say that it looked maybe something like this. Alright? Now let's continue. We will do the same thing for every category we have. So now we are going to take this for the number of exercise times per week for people who like exercising, and let's say that it looked something maybe like this. And let's draw the same thing for number of exercise per week for people who don't like to use their car, and the resulting Gaussian distribution maybe looks like something like this. Now, finally, we will do the same thing for how many kids they have for each category. So here we have this for the kids they have, how many kids they have, and let's say it looked something like this. And the same thing would go for people who don't like to use their car, and maybe it looked something like this. Alright? So the first step is to draw the Gaussian distributions. Now what is the next step? Now I want to show you something. Now let's say my dataset here contains 40 people who like to use the car. This is the number of data here, so here I have all the way up to 40, and here I have all the way up to 60. Okay? So first we are going to calculate the probability that something like to use a car. Okay, remember we have 40 people here and 60 people here. Now I'm gonna just be erasing those. Cool. Now the probability that somebody likes to use the car is actually depending on the number of samples. So here I have 40 samples divided by the total number of samples. So it is 0.4. And here, the probability that somebody does not ride like a car, according just to my data here, is actually 60 over 100, which is 0.6, right? Because I have 60 people and a total of 100. Now, this is the probability for if someone likes a car or does not. Now, let's say that there is a new guy came in and says, this is the new guy. He looks like this. And he said, hey, for me, I eat 2 times a day fast food, I exercise 2 times a week, and I have 1 kid. Where should this be categorized? Is he a person who likes to use a car or does not like to use a car? Well, we need to calculate that. This is what Gaussian naive Bayes will do. And the way to calculate that is by summing the following formula. What is the probability that he uses car? When? How many times? Does he eat fast food a day? 2. So fast food, when fast food equals 2, giving that he uses a car. Okay, this is what we call conditional probability, and we can simply find it right here. Let me just label this quickly. I'm going to say that this is for the fast food, this is for the exercise, and this is for the number of kids. And also, the yellow is for people who use the car, and the red is for people who don't. Alright? Now we have labeled our information. What is the probability that he uses a car? Well, we have already calculated that, which is 0.4. And we need to multiply that by the probability that he eats 2 times fast food, given that he uses a car. Well, we will go to the fast food here, and we need to get the likelihood. The likelihood for the fast food. So it is in the yellow. Let's assume that we found that the likelihood exists here. What is the likelihood? Well, it is the y-axis here, actually. All right. So let's say we know the number of times that let's say that here is the 2 for the fast food, right? So the likelihood is located just right here. All right. And let's say that this point here equals to 0.1. All right. That's so good. Now we need to add to this term after we calculate this, plus we need the probability that he uses a car multiplied by the conditional probability that he exercises 2 times a day, given that he uses a car. Again, here we have 0.4, and then we need to look at the likelihood of exercising when using a car. Let's assume that it is somewhere maybe here. I'm just making random guesses right now just to show you how it works. Now this will be multiplied by, let's say, 0.01 or maybe 2. And we continue. Now we will say plus, same thing, probability that he uses a car multiplied by the conditional probability that he that he has kids, let's say 1 kid, given that he uses a car. And then we do the same thing. Here we will say 0.4 multiplied by, again, we need the yellow, say it is right here. Let's say that we are multiplying this by 0.017. And then we add all of these results together. And let's say the final answer is, I'm not gonna be calculating this. Let's just say that this score is 0.03. Okay? This is just a random guess. And I will be registering this. So what we did here, we started with an initial guess saying that, well, this person here likes to use a car. And we got a score of uses a car. Let me register this over there. Probability that he uses a car is equal to 0.03. Okay, now We are going to repeat all of that, but for a different guess. And this different guess is going to be that he does not like to use a car. So I need to calculate the following. I need the probability that he does not like to use a car will be multiplied by the conditional probability that he eats 2 times a day fast food, given that he doesn't like to use a car. Okay, so we will be substituting this. What is the probability that a person does not like to use a car? It is 0.6. And we need to multiply that by the likelihood. But the likelihood will be used here is those red ones, because these are the distributions when somebody does not like to eat fast food. In our case, let's make it here. And well, let's say that this equals to, let me remove this. Let's say that this equals to 0.04, and then we will be continuing. Probability that he does not, multiplied by the conditional probability that he exercises, which is equal to 2, given that he does not. And again, we do the same calculation, 0.6 times, we need to locate where is the likelihood here for exercise 2. Let's say it is here. So let's say that this is 0.0002. And again, we do the same thing for the last one, probability that he does not. Of course, we are summing these terms. Just don't forget this plus this plus this. No. Of course, we are summing all of those. So this plus this plus this doesn't. Probability that he doesn't, multiplied by the conditional probability that he has kids, equaling 1, and he does not. And again, we substitute 0.6 times, let's say that it is right here, and this is maybe 0.3. And finally, we calculate this and we get a final score, and let's say it equals to 0.07. So we come here and we say the probability that he does not use, which is the calculation of all of that, is 0.07. Now we compare which one is higher. This one is actually higher, right? It means that this person actually does not use a car, depending on the information given. Now this is some detailed example on how Gaussian bias. Now this is some overview on how Gaussian naive bias works. Now there are more details, the algorithm, but this should give you enough understanding on how you can use it. Now we are going to go to Python and write this algorithm, but we won't be writing these details. But what I want you to note is that when we are training Gaussian naive bias, we are actually forming those Gaussian distributions right here. This one, and this one for every feature. This is the whole point of when we say training Gaussian naive bias so that it can make future predictions. It's all about those Gaussian distributions.